Our question is 5.1 gram NH4SH is introduced in 3.0 liter evacuated flask at 327 degrees Celsius. 30% of the solid NH4SH decomposed to NH3 and H2S as gases. The Kp of the reaction at 327 degrees Celsius is R equal to 0.082 liter atmosphere per mole per Kelvin. Molar mass of sulfur is 32 gram per mole. Molar mass of nitrogen is 14 gram per mole. Okay. Here we can use the formula PV equal to nRT, where P is pressure, V is volume, N is number of moles, R is gas constant, T is temperature. Decomposition reaction of NH4SH is as follow. NH4SH decompose into NH3 gaseous plus H2S gaseous. Using the molar mass, we will first calculate the amount of NH4SH in terms of mole. The molar mass of NH4SH in terms of mole is 5.1 divided by 51, which is equal to 0.1 molar. Given mass divided by molar mass. Okay. Given 30% of the initial amount have been dissociated. So the decomposition reaction of NH4SH is as follow. NH4SH solid decompose into NH3 gaseous plus H2S gaseous. Now given 30% of initial amount have been dissociated into 70% of NH4SH is left and 30% of ammonia and 30% of hydrogen sulfide will form. We will write the equation again. NH4SH solid, it will dissociate into NH3 gas plus hydrogen sulfide gas. Now initial concentration is, this is 0.1, this is 0.1, this is 0 and this is 0. Now we will use the 30% of initial concentration, then it is equal to 0.1 into 1 minus 30%, 0.1 into 30%, 0.1 into 30%. On solving this, it is equal to 0.07, it is equal to 0.03, it is equal to 0.03. So number of moles at equilibrium will be, this is at equilibrium. So total number of moles will be equal to 0.03 plus 0.03, which is equal to 0.06. We do not consider the number of moles of NH4SH here because we need to calculate the equilibrium constant in terms of pressure, and hence solids do not have any pressure. Using the total number of moles, we will calculate the total pressure at equilibrium using the ideal gas equation, okay, which is PV is equal to nRT. So P total equal to volume is given 3, number of moles is 0.06, we already calculated it, R is 0.082, and temperature, as we seen, temperature is, as we know, temperature is given, which is 327 degrees Celsius. We need to convert into Kelvin. So added 327 plus 273 Kelvin. On solving this, it is equal to 600 Kelvin. So temperature here 600. Okay. So Pt equal to 0.06 into 0.082 into 600 divided by 3. Now Pt equal to, on solving this, it is equal to 0.984 atmosphere. Now since the number of moles of two gases at equilibrium is same, then their partial pressure is also same. So partial pressure of each gas equal to 0.984 divided by 2, which is equal to 0.492 atmosphere. Okay, now Kp equal to partial pressure of ammonia into partial pressure of hydrogen sulfide. On solving this, it is equal to 0.492 whole square, which is equal to 0.2420 atmosphere square. So Kp equal to 0.2420 atmosphere. So Kp for the reaction at 327 degrees Celsius is 0.242 atmosphere square. So option 1 is the correct answer of this question.
Hello friends, the question is the value of a Kp by Kc for the following reaction at 300 Kelvin respectively. At 300 Kelvin, RT is equals to 24.62 and the reactions are given. N2 plus O2 gives us twice NO and N2O4 gives us 2 NO2. So the formula for Kp by Kc is equals to RT to the power delta N, where delta N is the difference of number of mole of product and reactant of gas, only gaseous reactant and products. So for reaction 1, N2 plus O2 gives us twice NO. Since we know that NO is also gas, O2 is also gas, and N2 is also gas. So the value of delta N for this reaction will be 2 minus 2, that is 0. So Kp by Kc for this reaction is equals to RT to the power 0, which is going to be equal to 1. Now for reaction 2, N2 O2 gaseous gives us 2NO gaseous. Here also we can see that N2O4 is gaseous and NO2 is also gaseous. So the value of delta N is equals to, the product has 2 and reactant has 1, which is equals to 2 minus 1 is equals to 1. So Kp by Kc is equals to RT to the power 1. Since the value of RT is given in the question, that is 24.62. So putting the value, 24.62 decameter cube atm mole inverse. So the answer is option D, that is 1 for reaction 1 and 24.62 for reaction 2. So the correct option is D. Thank you.